All right, it is a beautiful afternoon. It's a beautiful Saturday afternoon. And what better thing to do on a beautiful Saturday afternoon than an Algebra 2 lesson? Am I right? Of course I am. Actually, the day that I'm recording this, I hope everybody got to spend some time outside. I might go for a walk when I'm done with this. I'll let the video process. But we are starting lesson 6, and lesson 6 is titled Solving Simple Radical Equations. So I put the word simple in there, and you might be thinking, really, Miss Taylor, we're just going to do the baby problems. No, like that's not it at all. We're going to talk about what radical equations are and develop what I hope is a good coherent strategy for how to go about solving them. But radical equations can get really, really involved. They can involve multiple squarings, like where you square like everything and then you have to square it again, and you end up with like squaring things with big expressions under square roots, and they can get very, very messy, and we are not going to be tackling those. So we're just going to keep them pretty basic, get into the concept, and the concept does work for the more complex ones, but I mean, they could take multiple slides to even get through some of them. I taught them when I taught dual enrollment college algebra. We would do some of the messier ones. So anyway, before we launch into that, I wanted to spend some time talking about the task. Okay, so sometimes we get really caught up in what's the fastest way for me to get the points on this problem, and don't really take the time to back up and say, well, what are we doing? What is this problem? What am I being asked to do? Because what I'm being asked to do is going to drive how we move forward. So I'm going to start with this blank right here. When we solve an equation, what are we doing? Because solve is not a blanket word for get the answer. And I've actually had students tell me that, like, oh, it means to get the answer. Get the answer is really vague, and it can go with a whole lot of different kinds of questions. So a problem that said factor, the answer would be factors, but you aren't solving something in a factoring problem. Or a problem might say graph this line, and your answer would be some kind of graph. You would produce a graph to that, but you're not solving anything when you are producing the graph. So when we are asked to solve something, we're asked to do something really specific. We are looking for the value or values, because it might be more than one, of the variable. If it's a system, it'll be more than one variable that will make the equation true. This never changes, ever. This is what it means to solve something. Now, the way this can look can like manifest a little bit differently. If you've got a system, for example, you'll have more than one variable, so you're looking for all of the different variables. When you get into calculus, you end up doing stuff sometimes with 3 variables. You can do some interesting things with this. You might be asked to solve for something, which has a slightly different nuance to it, but basically you're looking for a value for your variable. And it's important to keep that in mind. Okay, now in this case, we're actually looking for a numerical value. And most of the time, that's what you're going to be looking for, some kind of a numerical value. So your answer will look like x equals 4 or y equals negative 1.2. Like you're looking for some kind of numerical value that goes with your variable. And if you produce anything else, you probably haven't solved the equation, with very few exceptions. Now, when we look at an equation, we see things being done to the variable, and that probably needs some clarification. So what kinds of things might be done to a variable? Well, maybe something like multiplication. So you might see something like 3x. So in that case, the variable has been multiplied by the number 3. Maybe subtraction. Okay, so you might see something like 3x minus 4. So in that example, the x is being multiplied by 3, and then a 4 is being subtracted. You might see, and this is where we get into today's issue here. Well, I meant to write square rooting, but I wrote squaring. So there you go. We'll square it instead. So there are these things that are being done to the variable. And in more complex equations, you have more things being done. So when you first start solving equations, you only have adding or subtracting, or only have multiplying or dividing. And then your teacher introduces, okay, let's say we have something like what I wrote here, you have subtraction and you also have multiplication. And then we get to things like quadratics, and then you might see some multiplying, some subtracting, and you'd also see the squaring, okay? So in general, like when we are asked to solve an equation, what we end up doing is that we undo those things. And so you would take a look at the equation and you would ask yourself, what has been done to the x? So you might see something like this, okay? Let's make it a 5, okay? So you ask yourself, what has been done to the x? Well, the x has been multiplied by 3 and 4 has been subtracted. So how would I undo subtraction? So again, we're looking at this general strategy. How would you undo the subtraction? You would, I hope, undo it with addition. And so you get your 3x. Now negative 4 plus 4 is 0, and 5 plus 4 is 9. And so you retain this balance to it. So you add 4, you have to add 4 to both sides to keep it balanced. Now we have gotten rid of one of the operations, one of the things that's been undone. And you'd ask yourself, okay, well, how do I undo multiplying? Well, I hope you would answer that by dividing. And so you would divide both sides by 3. 3 divided by 3 is 1, leaving you with x, and 9 divided by 3 is 3, and you end up with x equals 3. Now notice what has happened there, okay? We had an x and we did some stuff to it. Then we undid those things and we're left with a value of x that if I were to go and plug it back in would make that equation true. 3 times 3 is 9, 9 minus 4 is 5. So I would get 5 equals 5. That is what we're doing in every kind of equation ever, really. And when you get to more complex equations, like say a quadratic, you have to employ different kinds of strategies to get things undone. So for example, with a quadratic, you probably need to factor that x squared. And so we end up with those factors. What we're doing when we're getting those factors is we're figuring out a way to undo the squaring. So let's bring that to today. Okay, so this is a general strategy for radical equations. A radical equation is simply an equation that has a radical in it. Okay, it could be any kind of radical. It could be more than one radical. Okay, it's a big umbrella term. Like I said, these do get really messy. So on the left, I'm going to produce the steps, the general steps for how we would solve them. And what I'll do on the right of your screen is I'm going to work them out, and I'll try to keep it color coded so that if you're looking at this later, okay, I'll try to do this when I do the notes in class as well, so that if you want to pull the PowerPoint just to look at the PowerPoint at some point, you can see the color coding. So step number 1 is to isolate the radical. Isolate the radical. Now, in this problem here, this is my radical. Okay, it's the square root of x. To isolate means that you're going to get it by itself. So if you are like isolated, you're all alone. Okay, like I used to have a student, I used to have to put them on the island pretty much every day. On the island, to go to the island, if you have to be isolated. So in order to isolate the radical, we need to look at what has been done to the radical, very much like what we would do to solve an equation, okay, except we're just gonna look at the radical. We're not gonna worry about the radical yet. And with that radical, I can see that I have a 3 being added. So in order to isolate that radical, I need to undo the adding 3, which means I will subtract 3. And you have to do the same thing to both sides, or else it is no longer balanced. And that leaves us with the square root of x, and then 7 minus 3 is 4. Step 2. Once you have your radical isolated, and that might be 1 step, it might be 2 steps, okay, it might be a couple of steps, like things that you need to do to get it isolated. So once you have it isolated, then you are going to, I changed the color, but when I went back to the pen, it changed back. Okay, we are going to undo the radical. And this goes back to the first lesson in this unit. We said, what is a square root? What does it do? Well, a square root undoes squaring. And we have this idea that square rooting and squaring undo each other. That's what they do. So if I have a square root, the way that I am going to undo my square root, sorry, I'm trying to keep this color coded. Okay, now normally I do not do a separate step for this. Okay, so the way I would undo a square root is I would square it, because that's how those operations are related to each other, squaring and square rooting. 5 squared is 25, square root of 25 is 5. But to keep it balanced, I have to do the same thing to both sides. So I also have to make sure that I square the 4. And so the square root of x squared is just x, and then 4 squared gives me 16. Now you're probably looking at that and saying, looks pretty good, Miss Taylor. That looks like a value for the variable that if I plug it back into the equation would make it true. Yes, there is one more step here. So the last step there is just solve the resulting equation. Now, in this particular example, there is nothing left to solve, but it is very possible, depending on what was under the radical, what radicand you're dealing with, that you might have 1 or 2 additional steps at this point. So you're probably thinking, well, show me those 1 or 2 additional steps. Of course, it's a Saturday afternoon. Let's do it. So here's a couple of additional examples. We're going to go through 3 additional examples. And what I'm going to do is go back and reiterate what those steps are. Now, what you should do is you should have those steps in front of you. So hopefully if you're doing this from home and you were not in class, you are taking some notes, or you're watching this as a review and you've got some notes and you filled them in, so that in front of you somewhere you have the steps. You have the steps so that you can kind of use them as a template. So step number 1, isolate the radical. In this particular problem, this is my radical. It's a cube root, and the radical contains the radical itself, the index, and the radicand. That's all considered part of the radical. So in this particular problem, step 1 is already done. So we don't want to go into autopilot thinking every single problem is always going to look exactly the same. No, this one, there is no step 1. Just like the last one, there was no step 2. So step 3. In this one, now, the next step is to undo the radical. And again, I usually will just write this as part of the body of the work, but when I'm presenting it, I want to make sure I'm really clear about what we're doing. So this is a cube root. And if you think back to the very first lesson in this unit, a cube root undoes cubing. So cubing undoes a cube root. These are called inverse operations. So in this example, I am going to cube it. And if I cube the left, I have to cube the right. Otherwise, I'm not keeping my equation balanced. I have to do the same thing to both sides. Otherwise, they're not equal anymore. On the left-hand side, cubing and a cube root undo each other. And I would be left with 2w. And then 4 to the 3rd power is 4 times 4 times 4, which in this case is 64. Now, a common mistake that students will make, especially if they don't get enough practice, is they will try to cube the radicand. So they will try to do 2 cubed and w cubed. We don't want to do that. The cubing is taking care of the cube rooting. It's actually going to leave this alone. Okay, so what we're doing when we're cubing it is we're getting rid of that radical. We're finding a way to get rid of that radical by undoing it. Just have to make sure we do it to the other side. And now this one does have a step 3 where solve the resulting equation. So we have 2 times w is equal to 64. I would undo multiplication with division, and so we end up with w is equal to 32, and I have the value of the variable that will make the equation true. Next example. Okay, follow the strategy is good. Okay, the strategy is good. So we want to get that p all by itself. So the p is multiplied by 3. I have a plus 7. I have the whole thing square rooted, and then I'm adding a 2. Okay, and all of that ends up being equal to 6. So generally speaking, we're going to undo the things that have been done. All right, now I am adding a 2, but when I say I'm adding a 2, I am not talking about that plus sign right here. Okay? I am talking about the fact that the 2 is positive. If you had a minus sign here, you would still be adding the 2, but the square root would be negative. Okay? It's like a super easy thing to mess up. It just is. So if on your homework you see something like that and you end up messing it up, that's one of those like raise your hand, let's go over it. Let's kind of talk our way through like the minus sign versus something being negative, whether I'm adding or 2 and so forth. So to undo adding a 2, I am going to subtract 2, because remember what I'm trying to do is isolate the radical. Let me go highlight the radical. There's my radical. So I'm going to try to isolate it. It's the radical, the index, which in this case is implied to be a 2, and then the radicand, which is 3p plus 7. So I want to isolate the radical, which means I need to undo the radical, or undo the adding 2. And I will do that by subtracting 2 from both sides. When I say subtract 2 from both sides, what I mean is both sides of the equal sign, not, I don't know, but I'll see students like subtract 2 from the left side of the equal sign twice and not from the right side at all. So that equal sign is like the balance point. If you got like your I was going to say a teeter-totter or a seesaw, okay, that's your equal sign right in the middle there. So now that I have my radical isolated, now I need to undo it. So I've got the 3p plus 7, but it's stuck underneath the square root. I need to undo it. Well, how do I undo a square root? By squaring. And I just have to make sure I do the same thing to both sides. Got to keep it balanced. Okay, you can't just square one side of it, because then it won't be balanced. Now, remember that squaring is just going to deal with the square root. The square root and the squaring are going to cancel each other out, and I'm going to be left with the 3p plus 7, but I'm not doing anything with the 3p and the 7. Okay, they are still there. And then over on the right, I have a 16. And now step 3, solve the resulting equation, which in this case is a 2-step equation. So I will subtract 7 from both sides. And that'll leave me with 3p is equal to 9. And then divide by 3, and I get p is equal to 3. And there's our value of the variable that makes the equation true. At the time I'm recording this, I am working on grading the Unit 4 at-home test. And I am seeing like there's on it like a linear equation, and the number of students that aren't finishing it, like just like stopping at like 3p equals 9. No, like find the value of the variable that makes the equation true. So we want like p equals or x equals or whatnot. All right, last example. This one I need to look at because students will absolutely get thrown by the 3 out front. And so we want to just recall that that is multiplication. Okay, that's one of those things where if you've done all the work up to this point, you kind of intuitively know that. And if you're not sure, you would probably guess that. Okay. Yeah, you would probably guess that it was multiplication, but it is. And you need to be aware of that because the next thing you're going to ask yourself is, all right, well, to isolate my radical, I need to get rid of that 3, and that 3 is being multiplied. So in order to get rid of it or undo it, I would divide. And so understanding what that operation is, and not just replicating what a teacher has done, right? Not just replicating like, oh, well, my teacher did, a division step there, so I should. Well, I mean, yeah, you should, but we want to understand why. Okay, and then next step is to undo the radical. And so to undo a 4th root, I will raise it to the 4th power, and just make sure you're doing the same thing to both sides as before. A 4th power and a 4th root are going to undo each other. leaving you with 2x is equal to 81. All right, and then step 3, we're going to solve the resulting equation, which in this case is a linear equation, so we're just going to divide both sides by 2. And I think I would leave it as 81 over 2. I'm like, I don't remember this coming out to a fraction. I've used this problem before. 81 over 2. 9 divided by 3 is 3. 3 to the 4th power is 81, and it's a 2. Okay. All right. Great. Wonderful. All right, so 81 over 2. Now you could change that over to a decimal. That would be 40.5. You know, honestly, it doesn't matter. The only problem with changing it to a decimal is if you get a repeating decimal, you would have to round it, and then that would be considered not as correct when you have to round it. So keep that in mind. And it's an extra step. Like, it's a whole extra thing that you could get wrong. So I would just leave it. Simplify the fraction if you can. Okay, so for these practice problems, you're going to do these problems on a fresh sheet of paper to turn in for a classwork grade. Be sure your name is on it, and I will circulate to check work and answer questions, but we will not review it as a whole class. So I'm going to do the same thing in this video and allow people who are making up the work from home to get the same classwork grade within reason. So I will probably excuse you, like if you weren't in class, I'll excuse you from the classwork grade. But if you're watching the video and you're like, I would like that grade because I think I can ace it, then what I'll do is then I'll enable you to upload your work, and it just needs to be done within like the absence allotted window for missing the class that day. If it goes past that, then no. Okay, so you just have to do it within that makeup window. So we have 2 problems there. Obviously, pause the video and go ahead and work them out. Even if it's too late to get credit on them, go ahead and work them out anyway. All right, so let's move on to the next. So a few more examples. So we have here an example with more than one square root. And I had said at the beginning that these can get really awful. This one is not, because I did say we weren't going to go in really awful territory, but you can kind of start to see where under that umbrella of radical equations, where like if you have more than one square root, and yeah. So anyway, the steps that we have are to first isolate the radicals. So in this case, you have 2 radicals, and if you look at them, they're both isolated in that they're separated from each other with nothing else. Now, all it takes is like a little +1 over on one side, and now you have a much, much, much harder problem. But we don't. So if you have more than one radical, what you would try to do is isolate one of them. And what you would essentially do is you'd undo one of them, and you'd have this mess of stuff on the other side, and then you would undo the other one. So you'd repeat the process. You'd isolate the other one, and there's usually lots and lots of pieces going on with that. Now, in this case, where we are able to isolate both of them, then we can go straight to step 2. Now, if they were on the same side together, so if you had something like this, well, I didn't mean to make it positive, but okay. And you had a 0, as long as there was nothing over on that other side, what you could do is subtract 1. Now I did mess up the signs. Okay. And you could move stuff around in order to get them isolated. So just kind of keep that in mind. But these 2 being isolated, we can go straight to the next step, which is to undo them. And they are both the same kind of radical, which means they can both be undone with squaring. And when you square a square root, you're going to get what's inside. So g plus 1 on the left and 2g minus 7 on the right. And then step 3, solve the resulting equation. Now, I have had students say, well, basically the square roots cancel each other out. Yeah, essentially, that's what happens. I'm a little uncomfortable with students saying it that way just because I'm not totally sure what you're picturing in your mind. Like, when you say stuff cancels out, that can mean a lot of things inside, how we're processing it. But I keep like stretching my knee out. My knees are really bothering me. So, all right, moving on. So to solve this linear equation, we need to get all the g's consolidated on one side. So I will subtract this g. Now there's more than one way to do this. You don't have to do this exactly this way, but what am I doing? G minus g is 0, so I'm left with 1. 2g minus g is 1g. And then we would add the 7 to both sides and get g is equal to 8. Okay, or 8 is equal to g. Some of you might like that better. Honestly, doesn't matter. So you have like 8 is equal to g. And there's our value of the variable. That makes the equation true. Last problem. Now this one is actually not written as a radical. This one is written as a rational exponent. But we have learned in a previous lesson that rational exponents are just radicals. That anytime you see that fractional exponent, you can go ahead and write it as a radical. So this front loads the problem with a quick little rewrite. And does mean that you need to have covered the previous lesson. So if you're having a little trouble reading that because it's a little bit messy, this is 4x minus 1. The numerator is the exponent on the 4x minus 1, and the denominator is the index on the radical. Now, I don't need to do an exponent of 1. So what I'm going to do is erase that and the parentheses around it because I don't need them when the exponent is 1. And so if I don't need them, they're just making it cluttery. Now it looks just like other radical equations that we've solved. So we would isolate the radical by adding 1. Two plus 1 is 3. And then this is a fifth root. So I would undo a fifth root by raising to the fifth power. The fifth root and the fifth power are going to cancel each other out, leaving me with 4x minus 1 and 3 to the fifth power. I actually don't know off the top of my head. So we're going to go and do that. That is 243. I think I probably would have guessed that, but all right. And now step 3, solve the resulting equation. So 4x minus 1, we need to undo that minus 1. We'll make that a plus 1. Got to do the same thing to both sides. So we get 4x equals 244. And then we would divide by 4. This you might be able to do in your head because 4 goes into 24 6 times, and then 4 goes into 4 once. So it would be 61. Or you can grab your calculator and do it. And I apologize that I have run out of room. So I am going to sneak my answer up there. X is equal to 61. Okay, and I apologize for that. That bugs me when you guys do it, and I just didn't plan my space very well. So, but if you do have to put your answer in some other spot, do what I did. Draw an arrow, box your answer, make sure that it's clear that somehow the steps have gone out of the traditional order of top to bottom, left to right. Okay. So continuing the practice, this should be done on the same piece of paper as before. Okay, so wherever you did practice problems 1 and 2, now go ahead and add practice problem 3 to that and pause the video. And when you're done, come back. All right. So we've got a couple more things left to look at. So what about harder radical equations? I did say at the beginning, I said, we're just going to keep these fairly simple. We're going to look at the overall task and then look at this specific kind of problem and develop a strategy that's going to work for fairly straightforward ones. But radical equations can get very messy, involving more than one undoing of a radical. So if you have like 2 radicals, you might have to undo 1, and that's going to involve like kind of squaring binomials with radicals in them with like variable expressions under those radicals. and then you'd have to do a bunch of stuff to get the new radical by itself and undo them. Or something called an extraneous answer, which we haven't really talked about. An extraneous answer is an answer that comes from the algebra. So it's not a result of you making any kind of mistake. They are legitimate answers coming from the algebra, but do not actually make the equation true. And where they come from, they actually stem from, if you remember this idea where like if x squared equals 25, x could be plus or minus 5. But if it's the square root of 25, it's only the positive 5. That's where the extra root comes from. And it kind of comes from the fact that you might generate like this negative 5 somewhere in your solution that actually isn't an answer to the equation. And it won't actually make it true. That's where they come from. So checking your answers to make sure they work is essential. It's actually a must do. So a lot of times with the equations that we work with in Algebra 2, checking the answers is nice. That means plugging them back in, plugging those answers back in to make sure they still work. Is optional. It's like, if you have enough time, great, go ahead and do it. But with these, you actually have to plug them back in. So radical equations, you have to. Now, we can use Desmos to solve these equations as well. This is particularly important if we cannot isolate the radical or radicals. So if that very first step, isolate the radical, you can't do it. So maybe you have two different radicals and you can get one of them isolated, but the other one has some stuff with it that you can't get rid of without messing up the first one. Then this would be a valuable strategy. So we can't really leave this lesson without at least addressing that. I think we are back to recording. Okay. Yay. So I don't know what happened. Ugh. So the strategy for doing this on Desmos is you change the equation into a system, and you would graph the left side as its own equation. So I'm going to take x plus 5 to the 2/3, and I got that graph, which is actually pretty cool looking. And then I'm going to take the right side and graph that. And what you'll notice is there are 2 points of intersection. And remember what we're looking for in this? We're actually trying to solve for x. And so we are only interested in the x coordinate. And so here I would have x is equal to 13 and x is equal to 3. And so this actually generates more than one answer. And if I plug those in and I do x is equal to 13, so 13 plus 5 is 18, 18 to the 2/3 should be 4. Now I'm like, I want to go test that out. So 18, where's my exponent? To the 2/3. Oh, because it's negative 13. Okay, well, there we go. Negative 13. And probably half of you were like screaming that, like, Miss Taylor, it's negative 13. And just this is why we check our answers. And I'm like staring at it, and I'm like, that doesn't match. There we go, negative 13. So now so that would make it what? Negative 8. Let's try that again. So negative, I really hope that's negative 8. Negative 8 to the 2/3. Calculation outside of accepted range. I can't win. Like, I just can't win. That is my cell phone. This is what I get when I freeform it. Let's try just the 8 anyway. Let's just try the 8. Okay, the 8 works. And I don't want to fight with my calculator. I'm just using my cell phone, which I'm not super comfortable with. Anyway, there you go. So let's take a look at the next one. So this is one that will, okay, that will generate an extra solution if you do it out by hand. So let's look at 5 minus x, the square root of 5 minus x, minus the square root of x. Oh, and I forgot to put my y. It's like I start y equals, there we go. Well, that's interesting looking. And then we have y equals 1. And again, what we're looking for here is where they intersect. And right there, I see the point of intersection, and that would be where x is equal to 1, and there isn't any other, okay, there isn't any other point of intersection that we can see there. And you should be able to see that 5 minus 1 is 4, the square root of 4 is 2, square root of 1 is 1, and 2 minus 1 is 1. And there isn't anything else. But if you were to do that one out using our strategy, you would have to actually square it once. So you could get one of the square roots by itself, but not the other one. Now, the good thing about this is that you can use this to check your answers for all your regular equations as well. So even the simple ones, you can use this strategy to go back and check them. So that brings us to, oh, I have to stop the recording because I messed this one up. I'll see you on the next slide. Okay, so last practice problem. This one should be done on Desmos. This one is going to be one that generates an extra solution. So make sure you do this one on Desmos. Now this is a note for students doing this in class. If you finish before the end of class, use Desmos to check your answers to the previous questions. And then certainly if you're doing this from home, when you submit your work, you do need to submit all the work. If you submit some kind of crazy stuff for this problem, I'm going to know that you photomathed it, okay? If you end up doing stuff that I know I did not teach you in this lesson, okay, that have some like pretty mad crazy strategies, I am going to ask you to explain the steps. If you can explain all the steps and show that you understand them. Otherwise, nope, don't be copying stuff you don't understand, okay? So you should do this one on Desmos. You can go back and check your answers to the previous questions, and then be sure to turn your work into me. You can put it in my hands or the turn-in bin before leaving. Again, that's for in class, like if you're doing this from home, hey, don't leave it on my desk or anywhere else, okay? Not a safe place just to put a paper somewhere on my desk. That's not a good idea. Okay, now if you're doing this from home, you can have that classwork grade open. I would actually put on there, I was absent for the lesson, because in class, I'm going to circulate around the room and answer questions and confirm and check work for students as they're working. If you're doing it from home, those practice problems, you don't have the benefit of me circulating. So I would put at the top of it, like, I did this from home, and this is my best attempt, and, show if you got the wrong answer, show that you checked it on Desmos, and yeah, and I'll give you the full credit for it because that's obviously not quite the same situation. All right, so as always, you guys know how to find me, and I'm really sorry about that last slide. And if I did something ridiculous in the problem and I just didn't catch my mistake, I'm sorry. I'll try to go back and catch it now, but it's kind of hard right in the middle of recording. I should not go off script. All right, but let me know if there are other questions or concerns, and I will always do my best to help you out.